All right, so I greet you wherever you are. Today, we want to look at the chi-square test in Excel. Great, so I'm sharing my Excel sheet now. But before any other thing, please do me a favor, subscribe to this channel, and then recommend it to your colleagues to also subscribe. And then by so doing, you are supporting me. All right, so we want to look at chi-square tests. By the way, what is chi-square tests? Right. In statistics, there are several tests that are run, and one of them is chi-square tests. Chi-square test is actually used in making sure that we test the association between two outcomes. For instance, you have your observed outcome and you have your expected outcome. So you want to find out whether there's a relationship between the observed and then the expected, or the association between one variable and the other one was either due to chance or it was scientific. Was it random? Was it coincidence? Or there is actually an association? So that's what we use chi-square for. We try to test an association. So here we are going to look at, I just put some a few things here. So let me highlight and then maybe upgrade it a little bit so that it will be bigger. So we are looking at, in Ghana, our elections are coming up very soon. And so somebody conducted a survey and the person wanted to find out whether some people will vote, are ready to vote in the upcoming elections, or they will not vote. Out of that, so we have vote here, and then we have not vote. So we have male and then female. So we want to find out if people will be voting or people will not be voting. And we want to find out whether, as to between males and females, which of them stand the chance of participating in the upcoming elections. And so our survey, we surveyed a whole lot of people, and then we got this number. So let's look at how we're going to do a chi-square test on this. To do a chi-square test, there are about 4 steps. The first one is you have your observed figures as you have it here. The next thing is to calculate your expected values from here. And then the third phase is to make sure that, so here, these are our observed. So I'm just going to type the observed. And then when we come here, we're going to have our expected. So let me put that place expected. So that's going to be our, so we are going to do our calculations of our expected. So let me just copy this table and then I'll come and then paste it here. So that will be our expected. After we calculated our expected, we need to get the difference between the expected and then the observed. So here we are going to look for the difference between the observed and then expected. Then I'm going to close it up. And usually it is a mean square error kind of calculation. So I'm going to do this raised to the power 2, raised to the power 2 divided by the expected. That's what we are going to be doing over there. So it means when I get to this place, I am going to paste, I'm not sure the table is there again. So I'm going to copy this again, and then I'll come here and then paste it again. So let me just shift a little bit. So we are going to start with the observed. So these are the values that our survey has shown us. So we have to calculate the expected, and then we have to calculate this before we can now go to the fourth phase where we get our our chi-square. And then, so let's start with this. So when I come here, I'm going to delete all that you have here and leave. So when I come here too, I'm also going to delete the figures, and then I'll just leave this blank like that. So let's say, and then, so okay, I'll just leave them like that. So when I come in the first place, we need to, let me give it one more space so that, and then when I come here to, I can give another more space so that. So the first of all, when we get to the observe, we need to calculate the column totals and then the row totals. So we come here and we have our sum. So our sum value is here. So we are looking at this and I'm just going to close it. So that's going to give me my total. I'm going to drag it down. And then if I come here, I'm also going to look for the sum as well. And then I will just drag this. I don't know why this. Just a minute. I'm trying to. Yep, that's not what I wanted. So I want this, and then I am dragging from here up to this. I don't know why it's up to E7. Okay, then, and then I have the total. If I come here too, then the totals are there. So if I move here, it will give me the grand total. It's the same. So we have our totals, and then we also have our totals on the other side. So the row totals are here, then the column totals are also here. The next thing is to now come and calculate the expected values. So in calculating the expected value for those who vote and do not vote. So here, the expected value for observed value for vote is 34. What is the expected value for vote? Nil. So I'll come to that particular, and then here when we check our totals. So let me type there. Okay, because I put the equal sign. If I come, let me put here and then say total, and then also come here and say total. So we have our totals in all of them. So I'm now coming to calculate the expected. So if I come, I'm going to say this. So I will come to this particular column because here, this is the row we are looking for, but that's not what we are going to calculate. We are looking at the column total, which is here. You see, so we are taking this particular column total, multiply by, we follow the same row, the row total is here, multiply by this particular row, divided by the overall, which is the total here. And then that is all. So when I do that, but this is not too good, so I'll put it in bracket and come and say we look for the column total, then we come here, follow to the row total. So we multiply it by the row total, which is here. And then I'll close the bracket. And then I will say divided by the overall here. And then I have, that's the expected value. Then when I come down here, the next thing is to also check here, what is the, so it means this is the observed value. So when I come here to, I have to calculate the expected. So what is the column total for that? The column total is here. So I'm going to open my bracket and say this multiplied by which one? The row total. So from here, the row total is 104 multiplied by that particular cell. Then you close your bracket divided by the overall, which is here, the same way. Now, when I come here, it's the same thing I will also do. I come again, so it means for we're here. So we are looking at the total here and then the total over here. So it's going to be, I'll open my bracket. So this is the column total. Then you multiply by the row total because we are dealing with this value 70. And then I'll close my bracket, then divided by the overall total, which is here. Then enter. Then again, when we come here, it's likely to be the same value because we are dealing with totals. So if I come there, the same, I have this. So let me open my bracket first. It won't change anything, but for best practice. So you need to know how to be able to do this. And then also come here and say this. And then my bracket close divided by the total here. Then, so that's what I'm saying. It's likely. So we have our expected, which is also here. So now we have our observed values, we have our expected values. Remember, the totals we have here, we only use them to be able to make sure that we do these calculations. After that, we don't need much of it any longer. So I'm just going to highlight that part, and let us see that that part is no more necessary, or is no more needed, even though we will need it as we go along. So we have calculated we have our observed, our expected values who are also here. So what is the next thing? The next thing is to make sure that we get this difference. And here, when we come here, let me shift a little bit. When we come here, look at, we are going to use this algorithm on top there, which is observed minus expected square, all divided by the expected. So when I come to this place, I say this. So what is my observed? My observed is here, 34. But it's good to open bracket like this. So my observed is 34 minus my expected, which is here. We all get it. Then I put it into bracket like this. Then shift and then 6, it will give you that small symbol. Then you add 2 to it, which means raised to the power 2. Then divided by what they expected, the same expected, this particular. So when I do that, you see that it has calculated the mean square value there for me. So I go again to this particular point. From this particular place, when you drag it down, you are likely to have, and then when you drag it this way, it will do the calculations the same way. And then that is it. So here we have calculated our, we have our expected, and then we have our observed, and then we've also taken the difference between the observed and then the expected. So these values, as we have here, is what we are now going to use to calculate our chi-square. So the next thing to do is to calculate our chi-square here. So let me say our chi-square. So to calculate our chi-square is simply equal to all the sum of all the values which are there. So it's going to be the sum of all the differences that we have calculated here, and then close it, return. The next thing we need to calculate is our degree of freedom. Degree of freedom is always equal to number of rows minus 1 multiplied by number of columns minus 1. How many rows and columns do we have? We have, if you check here, there are 2 rows and then 2 columns. So 2 minus 1 is 1. 2 minus 1 is, so our degree of freedom, 1 times 1 is equal to what? 1. And then that is it. So the next thing is to calculate our p-value. And then, so our p-value is what is going to now give us whether there is a strong association between males and females as to whether they will vote or not. We don't know. So we come here and then we come and then calculate our p-value. And that's what we are going to use to draw our conclusion. So to calculate the p-value, we say this, and that's why we now have our chi-square distribution. So we use this particular function, chi-square distribution.rt. So this will return the right tail probability of the chi-square distribution. So we do this, and then we come and then we click on this particular cell. Then we click on the next one, which is also here. I don't know what's the problem with this thing is. See that I'm finding it difficult to. Okay, so what I'll do is I'll leave these parts. So let me come down a bit here and then do the p-value there. And say this is where I'm going to calculate the p-value. And so I can come to this particular cell, and then I have my chi-square distribution, which is here. So the first thing is to come and this, then I have comma, then come to this one, then close, and then return. So you see that our p-value is 0.0. And so you can see 0.0. I think that there are other zeros, but because maybe I have truncated everything here into 1 decimal place, that is why we are seeing what we are seeing. So you can see that when I come and click there, you will see the rest of the values. I reduce it to only 1 decimal place. So this is our p-value, 0.03. And you can see that 0.03 is way smaller than 0.05. So there is a significant proposition. So if we had assumed, if we had noticed that, if we had maybe set our hypothesis that more females are likely to vote as against men in the upcoming elections, then the hypothesis hold true that yeah, there's a significant conclusion to draw that more females are likely to vote in the upcoming elections than males. And this is how we do a chi-square test. But this is the simplest way to be able to do this. Now, let's go and look at the complex way to be able to do that. So by way of reminder, you would have your observed values like this. You have your expected, then you have you get the difference between the observed and then the expected. That's like a mean, a mean square value. And then after that, you take the sum of this to get your chi-square. You calculate your degree of freedom. Then you use your chi-square distribution function to be able to calculate the p-value and use the p-value to conclude. This is how we perform a chi-square test. Now let's look at a very much more advanced. So this is gender, and then this is the voting pattern. Obviously, if you had conducted a survey, so let me clear this. If you had conducted a survey, this is the results you would have had. You just interviewed a number of people, maybe about 100 or 100 and something people, as you can see, about 115 people. And then you notice that male and female, and then some say they will vote, others say no vote, some say vote, no vote, vote, no vote. So you want to find out of this particular number, is there a significant difference between those who will vote and then those who will not vote with respect to gender? Are males likely to vote in the upcoming elections as against women, or women are more likely to vote as against men? So this is how the data will come. And then how do you approach it if you are going to do a chi-square test of this kind of data? And remember, chi-square test, you are dealing with like categorical data, 2 outcomes, yes or no. You see, male, female, vote, no vote, and then in that order. So you are dealing with categorical outcomes, and these are the outcomes we've had. So this is where chi-square is really, really applied. So what do we do first? If you have data like this, if it is in Excel, click on any of the data that you want, and then go and click on your Insert tab, then click on Pivot Tables. Right. Now, this pivot table comes. Automatically, Excel will detect this. And then, you see, when we come here, it has already highlighted the entire data. And so, are we going to do the chi-square analysis in the new sheet? No, we want it in the existing sheet, so we click here. But we have to tell Excel where we want the new, which part of this particular existing sheet do we want the information to appear. So I will say that I want it to appear around here. So when I have finished, then I'll click on OK to be able to make sure that my pivot table is drawn. Now, the pivot table has been drawn, but that is not all. And when you look on you see that the pivot table field. Now, there are about 3 or 4 fields which are at the bottom here, right bottom here. Then you can see that we have the gender column, and then we have the voting column. We need to drag each of them and come and put them here to be able to create the table the summary table that we used earlier to be able to do the calculation. Now, the problem comes, where are you dragging this? Are you dragging the gender to the rows, or you are dragging it to the columns, or you're dragging it to the filter, or you're dragging it to the values? Which one is dragging to where? Now, let me show you how to identify that. When you look at the 2 variables, gender and then voting, which one is the cause, and then which one is the response? So here are the voting. So the voting, is the voting the cause of a male, or male is voting the cause of gender, or gender is the cause of the voting? Obviously, gender is the cause. So if you identify the field which is the cause, that field belongs to the columns. Any other field will go into the rest. So because of that, we would look at, we'll drag the gender and come and put it inside the columns. And then we will drag the voting pattern, and then come and put it in the rows. And at the same time, we'll drag the same voting pattern and come and put it. That's where we want to get our values from. And then when we do that, automatically, you can see that the table has been formed. So we have male, we have female, we have total, we also have no vote, we have vote, and then grand total. This particular table is formed immediately. So when we come here, we highlight the whole table, copy it, come down a little bit and paste it, come down a bit again, and then we paste it. Okay, so I'm going to paste it once more. So now this is the first table that we have. Now, this particular table, if you look at it, so under the female, we notice that 40 say they will not vote. And then, uh, uh, what is it? 21 say they will vote. Under the male, 22 say no vote. And then 32 say they will vote. In grand total, 61 females have taken part as against 54. And then we have our overall total here. Now, when you look at things like this, so in terms of the no vote, look at the total no vote. 62 people say they won't vote. 53 say they will vote. Now, when you look at this, it doesn't really carry any weight. These are quantitative figures. So in Excel or in data analysis, it's good to put this into some kind of percentages, so that when you put a percentage or a ratio on it, it becomes easy for you to interpret. So just click on any of the values here, and then you come to the value field under the pivot table, the value field here. You will see an arrow under the counting of voting pattern. You see an arrow there. Click that particular arrow. There's this small field that will appear, value field settings. Click on that. So it's going to show you this mini stuff. So we can actually do counting, we can do average and whatsoever there. But our interest is on show us this, show values as. So we want to show the values which is contained in that particular place as what's. So you can see no calculation. So click on this, and then you will notice that percentage of column totals. So when we click on that, and then we click OK, it will convert everything that we have there into percentages. So here, it now makes it easy for us to be able to see that, yeah, the 65.57% of female, of the total female who took part in the survey, say that they will not vote. 34.43 say they will vote. You see, and then when you go to male, 40.74 say they won't vote, and then 59.26 say they will vote. But are these particular differences, is this significant enough? Now, that is where chi-square calculation or chi-square distribution thing comes in. So when we come here, we will leave this second table as our observed, and then we'll come here, then highlight whatever that we have, and then we just click on and then we do our delete key. Sorry, I don't know what is happening there. So we just simply highlight here, and then we say delete. I don't know why it's not deleting. So we can make these changes for the selected cells because it will affect a pivot table. Okay. So here, what I'm simply trying to do is to make sure that I change this value here. I don't know why. It should be able to delete. Or maybe when I copy and I was pasting, I should have pasted it as values. Maybe that way it would have been better. So this is what I'm going to do. No, I would simply come and then copy this. And then when I get to this place, I'll paste them as values. That way, we won't find some of these things which are there. And then I'm simply coming to paste. Okay. And then I'm coming to paste. Maybe I need to copy the whole of this table to once more. again, and then I'll bring it up here and paste it as values. Yeah, so that way and so I leave the top table. So here I'm now assuming that this table here is my observed and the one here is going to be my expected because I'm going to calculate the. So because of that, I am deleting these 4 values, which are going to be my expected. Now these are my observed, and then these are my expected. So what am I going to do next is to make sure, let me increase the font size a little. So to make sure that I calculate the expected value here. Now check if you remember how we did the first one. To be able to calculate the expected, you are always looking at the row total times the column total divided by the overall total. So when I come here, I'll just do this. Follow by this particular cell here. You see, multiply by the other cell, which is here, and then I'll divide it by the overall total here, then I'll enter. So when I come to this place too, is the same. So best practice, I start with my equal sign, then I'm picking this, and then I will say, and so time is, I have this, then my bracket close, divided by, what is it, the overall total, which is here. It will give me the same value anyway. Then when I come to the mail to, is the same. So I have my equal to, open this, then I have my overall total, which is here, multiply by this, and then close the bracket, divided by the overall total here. It gives me the value, and then when I come here, it's the same thing. When you do something repeatedly, you master it. So we have this, and then you multiply it by the row total, close your bracket, divided by the overall, which is here, and then we enter. So now we have our expected values, which are here. These are now our expected values. So maybe I should give it red color. So now we've seen our observed and our expected. What is the next thing to calculate? I hope you can guess. We are now going to check, we are going to look at this, the observed minus the expected, all squared. And then remember this formula, raised to the power 2 divided by the expected. And so that's what we are now going to calculate. So we're going to put that here. And then here is our observed. This is our expected. Okay, so if I come here, I'll simply just do this. And so I will go and say my observed is, for no vote, is this. I think I should put it in bracket. It's always good. It's a good practice. And then minus the expected, which is here, then bracket close, then raised to the power 2, then all divided by the expected, which is here. And then that is all. So it's going to give me this value. If I move down, if I drag it down, it will give me the other ones. If I move to the other column, it will also calculate the others. And then that is it. So I now have my, what is kind of like my mean square where the error that I have just calculated. So which is now here. The next thing is to calculate my chi-square. And so my chi-square is going to be this. And then I will simply come here. The chi-square, like I told you, is equal to sum. We are going to, the sum of all that we have here. And then I'll just close it and then return. This is going to be our chi-square. Now we calculate our degree of freedom. Remember, our degree of freedom is number of rows minus 1 times number of column minus 1. And here we have just the same. It's going to be 1. So we have 1. And so the next thing is to now calculate our chi-square. We've already calculated our chi-square. Our p-value is the next thing, the most important thing. So our p-value is now going to be, which we say equal to our chi-square distribution, which is here. And then we pick the chi-square value. And then we come and pick the degree of freedom, then close it up and then return. So that's going to give us 0.007, which is way lower than 0.05, which is the 95% confidence level. So here we can say that if we had set our hypothesis earlier, and our hypothesis was that more males are likely to vote in the upcoming elections, then the hypothesis holds true that we're likely to have more males voting in the upcoming elections as against women, with a p-value of 0.075, which is way significant. So this is how to do a chi-square calculations and to be able to do other things. It's very easy. I just decided to go from the lower parts, and then we come to the upper part. And then in that case, I've shown you how the data will come, and then how you yourself will be able to use the data, convert it into pivot tables, then do all that you need to do, and then you get to your final answer, which is what we have here. So if I come here, if I highlight this, and then we are good to go. This is the value that we are looking for. So that is it for chi-square calculations. Next time, we'll try and look at the t-test, and then we'll look at z-test. Thank you. My name is Biba Bright. If you like my videos, please subscribe to the channel and then give me a thumbs up. Bye-bye.